Hello, welcome, namaste, bonjour, wherever you're tuning in from. Welcome to Syntax. I am Kritika. I am a project manager here at Leapfrog, and I will be your host for this 3-day event. For those of you who do not know, let me just give you a brief introduction about what Syntax is. So Syntax 2021 is a platform to share well-formed ideas, thoughts, and innovations around IT and tech. It is an environment for tech enthusiasts to foster conversations that shape the modern IT world. Through this global conference, we want to inform, educate, connect with aspirants as well as professionals from around the globe who will shape the modern IT world. All right. And with that, let us take a look at the itinerary for today. So we've got 3 speakers lined up for today. We've got Luca Mezzalira, Principal Solution Architect at Amazon. We've got Sparsha Dotil, who is the lead DevOps engineer here at Leapfrog. We've got Minko Gechev, who is a developer relations lead at Google. We've got 2 lightning sessions in between. For them, we've got Kailash Vijayananda and Swecha Bista, both from Leapfrog. All right, I guess with that, we can start off for session 1. With almost 2 decades worth of experiences in the industry, let's welcome Luca onto the speaker's platform to hear more on Micro-Frontends decisions framework. Welcome to the floor, Luca.
Thank you very much. Thank you for having me. It's a big pleasure for me being here, and I hope you will enjoy the talk. So let me share first my screen, and then we can start, I guess. I think you should be able to see now.
Yes.
Fantastic. Okay, so thank you for joining. And today I'm going to discuss about Microfrontends. Microfrontends is, I cannot say a new trend. It's been a while that I'm talking about that, but I still think that there is, we need to understand deeply what they are and how we can leverage the power of this architecture pattern, because sometimes could be misunderstood. And today I want to introduce you to the principles of Microfrontends, as well as a mental model that I created in 2019 for approaching any Microfrontends architecture. I'm a strong believer that if we have a North Star to follow for creating an architecture, it becomes extremely easier follow that North Star for taking all the decisions needed. And that's basically what I try to design with the decisions framework. Okay, so my name is Luca. I'm a principal solution architect in AWS. I'm an international speaker and an O'Reilly author. Let's see if okay, so let's start first of all with the definition of what Microfrontends are, because it's very important that we frame what they are and deeply understand what they are before moving forward. So Microfrontends are a representation of a business subdomain, allow independent implementation with same or different technology. They minimize the code share and they're owned by a single team. So as you can see in this definition, I highlighted quite a few terms because I think are key for then understanding how to structure your applications with Microfrontends. So the first one is technical representation of the business subdomain. So if you're familiar with domain-driven design, a business subdomain is just a portion of your application. If you think about an e-commerce, for instance, you can have like the authentication part, the authentication subdomain that is composed by the sign-in, retrieve email, retrieve password. You can have instead the payment subdomain. You can have I don't know, customer support subdomain. You can have the catalog subdomain, and so on and so forth. You can slice your application based on how your domain is structured, and because of that you can easily identify portion of your application that are available. Moreover, we can we can then talk about independent implementation. Because one of the key characteristics of Microfrontends is the fact that after identifying these subdomains, you need to be able to independently deploy them. And that's a very key characteristic. The moment that you start to see that you deploy multiple Microfrontends at the same time, every single release, it's probably time to go back to the whiteboard and start to understand if the way how you slice your Microfrontends is still right. I'm saying it's still right because it could happen that at the beginning are perfectly fine, you deploy independent microfrontends, but because the business is changing, because the environment is changing, and the context where you operate is changing, it may well be that after a few months or few years, you really need to revise your boundaries. Same or different technology. Often microfrontends are associated with the idea where you want to create a system or an architecture for using multiple UI frameworks. It's not exactly true. Despite you can, it doesn't mean that you have to use multiple frameworks. And my suggestion is everything that is viable for a server-side rendering or a single-page application is also true for microfrontends. Therefore, the only time that I see a good use of multiple frameworks is mainly when you are transitioning from a legacy or multiple legacy applications towards microfrontends. In that case, I think it's tolerable having multiple frameworks that are creating a unique experience for the user. Obviously, it will have an impact on performances, but in the long run, you know that you're going to move towards a unique framework, and therefore that will be your final goal. So for a temporary period of time, meanwhile you are creating and deploying in production your microfrontends alongside the legacy application, I think is tolerable. Then minimize code share is probably the most controversial part of this definition. I know that we are used as developers to share our code and trying to take, for instance, similar code and abstract in a way that is reusable across the application. But unfortunately, more often than not, what happens is that we are doing that, but without taking into consideration how many times really we're going to use that. It's uncountable the amount of projects that I've seen where we started these abstractions and then we used twice inside the entire project. We didn't use anymore, and we spent a considerable amount of time for creating this abstraction, but in reality it wasn't used as expected. So for me, it's very, very important that we are minimizing the code share when we are talking distributed system, because otherwise we are creating coupling between distributed entities. And the moment that you are creating coupling, you are basically not only coupling on the technical side, you are coupling on the organizational side. That is even worse, in my opinion. When you want to use Microfrontends is a mechanism that you want to decouple your teams and make them running in parallel. Then obviously there will always be something that has to be shared. Think about the design system or login library, stuff like that. Yes, definitely you have to share, but you need to minimize and be aware of what you're going to share and what's not. Finally, ownership part. I know that seems, let's say, a basic concept, but unfortunately, it's not always. So a microfrontend has to be owned by a single team. That doesn't mean only one team should contribute to that code base. It means that they are responsible for building, for owning and maintaining that code base. And that means if another person is going to contribute, that team that is responsible for operating the microfrontend in production, it will always be the last team saying, yes, this code is going to be production because then I need to maintain and I do understand that code or not. That's a very important concept. So pragmatically speaking, a microfrontend is basically, imagine a single page application, as you can see in this slide, that is composed by multiple subdomains, and we try to identify them and extract and deploy independently. What you discover with this exercise is then sometimes users are behaving slightly different. In a single page application, user has to download the entire code base in order to start and see, for instance, I don't know, the sign in or the landing page or whatever other view that you have inside your single page application. With microfrontends instead, they download only what they need at the time that they need that, because obviously the moment that you have, I don't know, a landing page microfrontend that is downloaded, and then the user stop there, it won't download any code related to the sign-in logic or the sign-up logic and so on and so forth. At the same time, if after a while the user wants to move forward after the landing page towards the sign-up procedure, and they can do that, and they will download the next experience. And I think this, let's say, is optimizing by default the application that we have. Then I define a few principles that I think we need to bear in mind when we are designing our applications. So the first one is that we model around business subdomains, and I think we extensively discussed before in the definition. The second principle is that we are decentralizing. And decentralization is not just a decentralization, a technical decentralization, is also, and probably more importantly, a decentralization of decisions taking. And when I'm talking about that is if before we had like a centralized team, if you want, or group of people that were defining the LinkedIn strategy, how the best design patterns, the framework to use, the testing strategy, and all the other things. Now these, and usually were architects or tech leads or principals, now we are deferring certain of those decisions to the teams. We have this group of people that are defining some guardrails where the teams are working. For instance, we want to decide that we are going to use TypeScript for this specific application. So this team of architects and principals are definitely saying, okay, those are the technologies you can use. Those are the, I don't know, patterns for fetching some, consuming some APIs that you can use. But in reality, many decisions are taken by the team that became the domain expert. So how you want to leverage certain things has to be decentralized towards the teams. The other thing is, in distributed system, one of the most important investment that you can do is around automation, and therefore you cannot say like you have in a single page application, I define my automation strategy and I will maintain for the next 5 years. With Microfrontends, you are constantly iterating and trying to create a feedback loop that is really fast. Because the reality of the things is you are not doing automation only for delivering an artifact, but you're creating automation for create confidence to your teams that they are developing the right things, and the things that are going to deploy is not going to break the existing application. Independent deployments we discussed before is very, very key. Try to figure out when you are designing things that you don't have always to deploy multiple microfrontends. Otherwise, there is a design problem. Hide implementation details. When you work with microfrontends and then you have components maybe that are shared across multiple microfrontends, one suggestion that usually I provide is work with API contracts, and therefore define API contracts between the teams and then having the team working in parallel. That is a technique that we are using on the back end for a long time, and we should start leveraging this approach also for the front end. And finally, there is a new dimension that we need to take into consideration when we think about microfrontends, that is the isolation of failure. It could happen that you have multiple microfrontends in the same view, and maybe one is not, let's say, loaded for network issues or for a bug in the system. It doesn't matter. You need to think about that and how your application will react about this event. It's going to hide the portion of the microfrontend is there. It's going to throw an error to the user. You need to think deeply about the failure part, because it's something that could happen and it will happen. Okay, so now, based on those information and based on those principles and the definition that we have seen, I created this decision framework. As I said, it's a mental model for implementing microfrontends architecture, and it's composed by 4 key pillars. You have to identify what a microfrontend is for your system. You need to understand how you want to compose microfrontends, how to route microfrontends, and how to communicate. Those are the 4 key decisions that you need to take upfront, and that will guide all the other decisions, how to implement your design system, how to do observability, and so on and so forth. The important thing for me is if you decide one of those, and during the process you decide to change for any given reason, maybe change the perspective, maybe you didn't have all the requirements to take the appropriate call, to make the appropriate call on a specific decision, yes, you can change, but trust me, it could be painful changing those. So therefore, spend the right amount of time for defining them. Okay, let's start with the first one. When we want to identify a microfrontend strategy, you can pick 2 of the possible solutions. You can have multiple microfrontends on the same view, what is what I call the horizontal split, or you can have one microfrontend loaded per time inside the application, and that is what I call vertical split. So The differences between the two are those. When you think about horizontal split, so you have multiple teams working together for the contributing on the final view for the user. You first have an upfront investment. You need really to understand how the things are working, streamline your developer experience, and therefore, if there are missing tools or you have certain requirements, you need to build some tools in order to maintain that. Nowadays, is a bit more mitigated this aspect, because if you use certain frameworks that are available in the Microfrontends community, you can have that done for you. But again, it really depends context by context, because every environment has its own best way for approaching that. The other thing that you need to think truly is the team structure. You cannot afford to have this kind of architecture if you don't understand how the mechanic works between teams. So imagine that you have 3 teams contributing for the final view. Who is going to be responsible for the final delivery? Who is going to assemble everything? You need to figure out what are the best strategy. It could be that you have one team that is leading the final view, or you can have like different people that are contributing together from different teams, and they create a group of, if you want, leaders that are defining the path for all the 3 teams. However, in any decision that you want to take, you need to set up and have a crystal and clear strategy for that. Testing challenges. Obviously, when you do this, every team contributes to a specific portion. So if you have multiple microfrontends in the same view, you need to figure out ways for doing unit testing. Integration testing is more or less the same. It doesn't change much, but end-to-end testing can be quite problematic. So you need to figure out the right way for handling those kind of challenges. Scalability challenges. If you decide to use server-side rendering, for instance, for your microfrontends, then you need to make sure that your server-side render architecture, maybe on the cloud or on-prem, is able to supply to the traffic that you have. So if you have burst traffic, you need to create an architecture that is scalable enough for affording all the traffic that you need in order to serve your microfrontends, and then maybe implement caching strategies, CDN, and so on and so forth for mitigating the strain towards the origin. Dependency management is another challenge. So if I have a microfrontend, multiple microfrontends in the same view that are using similar dependency, I need to have a way that I can centralize those dependencies and download for the user once and not multiple times. And there are ways to do that. You can use System.js, for instance. You can use Module Federation. There are plenty of solutions out there. Or you can create your own custom solution. Obviously, it depends of your context. On the vertical split side, you have a more traditional development. At the end of the day, what we are building is a static HTML page or a single page application. And those are the 2 flavors that you can have in a vertical split. You are fully embracing the JavaScript ecosystem, so you don't have to create custom tools, because at the end of the day, what tools are available for building a single page application are available and viable for these architecture. And finally, many people are saying single page application and therefore vertical split microfrontends are not great for SEO. I would suggest to check dynamic rendering. That is a technique that was introduced by Google several years ago for providing an optimized version of your single page applications to crawlers. And therefore, when you identify the crawler, you are going to serve not a single page application, but a static page that is heavily optimized for SEO purposes. So on the composition side, second decision, you have 3 options. The first one is a composition client side. And usually what you have, as you can see here, you have your microfrontends that are living on the origin. That could be either an application server or, for instance, in the case of AWS, an S3 bucket. And what you do usually, you put in front of your origin a CDN, because they are static assets. Therefore, instead of going every time to the origin, you just use the power of CDN in order to reduce the round trip to the server. And then you have an application shell, or therefore a container that is responsible for composing the microfrontends. This technique, this composition technique, is used either with vertical or horizontal split. But bear in mind one thing: vertical split makes sense only with this composition. Therefore, the moment that you say, I want to create a vertical split application, any other solution that I'm going to present you, it's technically viable, but I don't recommend that because you're not leveraging basically the technology properly, because you're not gaining any let's say plus on using this, any benefit of using that. Therefore, in this case, the application shell is loading multiple microfrontends in the same view, or one microfrontend per time. The second option is edge side includes. Edge side includes is a markup language that is available for a long time, was created by Akamai and Oracle and a few other companies, and basically everything is happening at the CDN level. What happens is that you have this markup language similar to HTML, and they at the CDN level, they are composing your final view. And the beauty of this is that you can really, let's say, scale your content, especially if it's static content, because you can easily do that at the CDN using all the different point of presence that are available on CDN. There are some pitfalls. So the first one is not all the CDNs are implementing edge side include. The second one, if it's implemented, it doesn't mean they respect all the specification of the language. And the third one, the developer experience is far to be optimal. Currently, only Akamai has, let's say, thought properly about the developer experience for this part, but in general is a bit complicated. Therefore, this one usually is suggested for static content. And therefore, if you have, for instance, a catalog, IKEA used a solution like that, but they had to implement an additional transclusion mechanism, therefore substituting part of the DOM with dynamic content using client-side include. That basically is the same mechanism on edge side include, but it's happening on the client side. So when you find a placeholder tag, it's going to be replaced with a more dynamic code based on JavaScript and HTML. And therefore, usually you have edge side include and client side include that are working together if you want to create something more dynamic than the static content. The other thing, and probably the most powerful and complex solution, is the server-side composition, where you need to think, obviously, everything is happening on the server side. So you compose your different, let's say, part of the application, multiple microfrontends in the same view usually, and usually you have a CDN for offloading some traffic to the origin. But the interesting part here is that you have the maximum flexibility. You can control literally to the byte what is going to be served to the customer. Then when we move to the routing part, again, we need to take into consideration the previous decision for the composition side. And in the routing part, usually if you are talking about the client-side composition, is happening at the client side inside the application shell. Therefore, the application shell is aware what are the first level domain that it has to load. Therefore, my site, the .com/catalog is first level domain, and he knows which microfrontend to load, or /my account, and he will know which my microfrontend to load. The other option that is viable is using computation that is happening at the CDN level. So, for instance, CloudFront uses Lambda at the edge that allows you to have a bit of computation that is happening on the CDN level. Or close to the CDN level. And the beauty of this is that you can potentially request a URL to CloudFront, and in this case, this will trigger the computation layer that will serve the right static assets for you. And then you can implement, let's say, powerful mechanism like canary releases or blue-green deployment, or even a strangler pattern directly at the edge without polluting the code that is in the application shell. The other option for edge side include is using, obviously, the routing is happening on the edge, or better, where every time you have like a one-to-one mapping between the URL and the page. Therefore, every time that you change the URL, you go through the CDN. CDN will compose everything and will provide the new page. And on the server side composition, everything is happening again on the server. So no surprises there. Finally, the communication. It's very important to understand that if you have an horizontal split and therefore multiple microfrontends in the same view, you need to maintain a decoupled communication. Having something like a global state management is an anti-pattern. And therefore, in order to maintain decoupled your microfrontends, usually use techniques like an event emitter, custom events, reactive streams, signals library, whatever is similar to a pub sub pattern. Yes, that would be probably what you are looking for. This because it will allow you to maintain independent your microfrontends, but will allow you also to communicate between microfrontends in a loosely coupled fashion. Either that you pick vertical or horizontal split, then sometimes you need to communicate when, for instance, you have multiple microfrontends in an authenticated area. How can you share, for instance, the token? Usually you do for persistent, let's say, information like a token, you use cookies or local storage or session storage. Instead, if you have ephemeral or volatile data, like, for instance, an ID that you want to pass, ID of a product that you want to pass from one microfrontend to another one, you can pass through query strings. And then the microfrontend will know that the next microfrontend will know that has to retrieve from the query string the information that is needed in order to consume other APIs. So those are basically the decisions that you need to take during the design phase of microfrontends. Obviously, as you can imagine, are not the only decision that you need to take. And it's important for me to highlight the fact that then there are other decisions that are cascading from those that we have seen. And what kind of challenges we are going to face? So first one, automation. So as we said before, a principle that we need a culture of automation. Automation is an important part of microfrontends. Using infrastructure as code, for instance, can allow you to streamline your automation and provide similar experience for multiple teams, and basically creating a baseline for how to build microfrontends. But then you need to empower the team to take decision for optimizing their code base using the tools that are needed inside their pipeline. Observability is another one. Think about how I can identify in production when a microfrontend is failing, which one is failing. There are tools and libraries like, I don't know, LogRocket, New Relic S1, Sentry is another one, that are allowing you to understand where the project is failing. And you can integrate them with your microfrontends and immediately identify where the problem is. Code sharing. If you share the code, it's fine, but bear in mind that you are creating an external dependency for a team. So you need to understand if it's really needed or not, because otherwise you are losing a bit of the possibility to run in parallel multiple domains. I think that it's very, very important that we don't start to go in the rabbit hole of sharing tons of components, but try to be pragmatic here and trying to be concise. Design system is definitely something that you need to share. It's definitely applicable with microfrontends, and depends from which framework you're going to use. There are different implementation process. I think it's very important to understand that you can have a cohesive and coherent user experience despite you are using microfrontends. Performance. You can have performance with microfrontends, definitely, and moreover than not, you are going to have even better performances of a single page application, for instance, because you are not going to download everything upfront. And the interesting part is everything that you have learned for optimizing server-side rendering application or client-side rendering application are applicable with microfrontends. Depends which strategy you are going to take, and if you apply the same performance optimizations, you will be able to strive also with microfrontends. Finally, architecture is not only a technology problem. Architecture is also an organizational problem. You need to revise your organizational structure to make sure that your architecture can strive inside it. It's very important to understand that communication flow, organizational structure, and technology are going hand in hand in order to create a successful product. I would like to leave you with this this important thing that probably will I hope that it will stick in your mind. Architecture is always a trade-off. There isn't right or wrong. What is working in one context may not work in another one. You really need to understand what is your context and find the right balanced approach for what you need to build. Therefore, don't blindly say, oh yes, PayPal was using or Amazon was using that specific framework, so it's going to work also in my context. Try to understand if your context is overlapping with the Amazon one or the PayPal one or whatever, and then trying to apply a sensible approach for your project. I will share the slides later on. Here you can find quite a few other material that I created or is available already in the web. There are quite a few interesting parts on if you want to go more in deep about what I discussed. I touch quite a lot of points, and you can find more information there. I would like to thank you for having me and also for listening to me. If you have any question, happy to answer right now. Otherwise, if you want to reach me out personally, you can find the email in this slide. Thank you very much again, and we can open the floor to questions.
Well, that was wonderful. Thank you, Luca. We do have a team collecting all of the questions from the chat. So
Great.
Let me place one of the questions that we received. This question is from Chumlung, and he asked, how is micro-frontend different from microservice architecture? Can micro-frontend be considered a subset or an implementation of the microservice architecture?
Yeah, that's a good question. So microservices is an architecture that is working mainly on the backend. Microfrontends are leveraging similar principles as you have seen, but on the front end. And therefore, they can work together. So you can have microfrontends and microservices working together inside your system, or you can have one of them. So you can have microservices that are working with a monolithic code base on the front end, or vice versa. It really depends what you need to optimize for, but you can use, I cannot say it's a subset of microservices, but I would say are equally important architecture, but for different targets, one front end, one backend.
All right. Next question that we've got is, what do you think about the testing approach for the application? As we are dynamically loading the content, it can be harder to have a final picture of the application.
True. But so if we start to think about the different testing approaches, you usually do, let's say, unit testing and integration testing in isolation, so it shouldn't be a problem in that part. The end-to-end testing, you need to have an environment where you can run it. Then if you're running that dynamically, if you're loading your content dynamically or not, that is just an implementation detail, but the problem is exactly the same you can have with a single page application. Now, I agree with you. There are some challenges on how you are going to load other microfrontends if you're not responsible for them, but there are definitely solutions. For instance, Webpack has the dev server that will allow you to map specific URL to a remote endpoint. Therefore, you can say, every time that you see mysite.com/catalog that is not my microfrontend, go to my staging environment/catalog and pull it from there. So and therefore, you have the end-to-end experience inside your laptop, and your developer experience doesn't suffer.
Okay. Next question that we have is from SERHIY. I don't know how to pronounce your name. I'm sorry. But the question is, how to prevent container catching an error from child failure isolation?
Let me see if I get it. So are you asking, so if how the application shell can prevent that is going to block the entire application?
Serhi, if you're not actually, you can
Okay.
unmute yourself if you want to rephrase your question in any way.
Yes, hi guys. So
Hi.
my question is, let's imagine that we are going with the horizontal approach. Horizontal approach.
Yeah.
I have a container application which will load and bootstrap the children on the page, and let's assume that it's a client-side rendering happening. So considering that each micro-frontend should be independent, but in case some of them start to shooting exceptions, and those exceptions can be captured by container, because for example, with the Sentry, if it seems that it also catches on both sides, it goes into a container and also within the child. Yes. So do you have any ideas on how to deal with this? Because it's a pretty difficult.
It is difficult. And I remember when we implemented the first time in my previous company, it took quite a few weeks of a couple of engineers in order to do that. The thing is, you need to be, let's say, smart in the way how you handle those things, using try-catch statements inside your code for preventing certain situation, and then communicate with Sentry in isolation usually is what was working best for us. And moreover, the main challenge at the beginning was coordinating a centralized instantiation of Sentry and then a decentralized implementation on Micro-Frontends. So that will require a bit of effort, but definitely is doable because we had that implemented.
So just to understand if I understood correctly, so
Yep.
it's a kind of a custom approach. So I need to try catch manually, and then let's say like me doing communication to Sentry of that specific error.
Potentially, yes. That was because then we, for at least in our case, we started to also send custom errors in order to understand the, let's say, sometimes it could be an error that maybe it doesn't prevent you to run that specific Micro-Frontend.
Awesome. Thank you so much, Luca.
You're welcome.
All right, we've got the next question. Doesn't this make development harder? How do you deal with window pollution with different libraries and tracking DOM tree changes with Micro-Frontend?
Yeah, so it really depends which approach you're going to take. I give you a couple of examples. So when you have multiple libraries that are, let's assume that you have like classic library, Moment.js, that you have different version in the same system, that because obviously are distributed teams, therefore potentially it could happen. So you have different approaches for mitigating that. You can either create a fitness function in your CI, and definitely you are checking that all Micro-Frontends are using the same version. Or you can use System.js or import maps for ES6 or module federation that will allow you to basically segregate the scope of your library, and therefore there won't be a clash between same library, different versions. And that is also true when you have, let's say, multiple UI frameworks, for instance. Personally, I would recommend to have, let's say, a bit of coordination. It doesn't mean that when I say teams has to be independent, it doesn't mean that they don't talk with each other. One thing that we learned in the hard way in my previous job was we started to, let's say, create these independent teams, and then we realized that we had to align them in somehow. So the principal role, as well as multiple documents that we, for instance, we were using some documents that for aligning the different teams, and everyone can contribute to them. We created like a community of practices where they can share best practices that were happening. We created also in a specific, let's say, moment of the development, groups of people that of different teams that has to coordinate, like for instance, let's assume the Sentry example we discussed so far. So we take like few people from different teams, and basically we have every week a stand-up where we update ourselves in order to understand how the things are going. The fact that they are independent, and that's why I put a lot of emphasis on the organization structure, doesn't mean that you need to create silos. It means just that you need to deal differently with a certain context.
Okay. All right, we've got the next question ready, and this is from Chulindra. As a developer, what is the difference between monolithic frontend and micro-frontends, and why micro-frontend matters?
Yeah, that's a good question. So a monolithic frontend is basically a unique code base that is containing all your code. Therefore, imagine that you have, I don't know, tens of developers that are working on this code base. You start the project with all the best intentions, but obviously you start to have maybe people leaving the company after a few years, and then you have like new frameworks that are coming up, new best practices in the front-end world, and then integrating in a cohesive way inside the code base can be non-trivial, because the reality of the things is that you have this code base that obviously is, you're adding new functionalities, fixing bugs and other things, and has a certain structure. So if you want to change that or implement a new pattern, then you want to implement not only on part of the code base, but in all the code base. And moreover than not, then you need to start to create this monolith, and you start to extract certain bits in shared libraries, and can become, let's say, complicated in the long run to maintain. With microfrontends, instead, we are taking an approach where we isolate by design not only the code, but also the organization. Therefore, we have these teams that should be independent, as we said before, and then they contribute to a unique experience for the user. So the aggregation can happen at compile time or runtime. And microfrontends matters, especially when you have, let's say, large organization working with tens of front-end developers on the same project, or you have a multi-tenant application where you have one application that is similar but not identical for different customers. So in that case, you can customize just one portion of the application, and you are not when you deploy, you are not going to impact the rest of the application. Also, catching bugs is another side effect of microfrontends. You can isolate a bug without affecting the rest of the project. If you think about microservices, the benefit that you have there will be the same, similar of what you have on microfrontends.
All right, thank you, Luca. We've got one more question that states, any recommended approach for common state sharing between different micro-frontends? And this comes from Nabin.
I cannot recommend, let's say, an approach, because again, it depends from the context. It depends, do you want to have server-side rendering application? Do you want to have client-side rendering? Do you want to have edge-side include? It's difficult to say. So I think the decisions framework is, and that's why I created that, should lead you to filter out the options that you have. Because if you start if you take a step back and you ask me which is the best approach, I can tell you it depends, as a good architect would say, because it depends from your context, depends which, let's say, approach you're going to take. The decision framework is there for guiding you towards, let's say, the right, let's say, set of tools that you should pick, and that's why I created that.
All right. If you have a follow-up question to the question that I've placed, please feel free to drop them on the chat as well. Next question. This is from Vic. Our legacy application has been using Redux. Sharing the store between the container and micro frontend is not a good practice. I tried a solution to use a pub sub library to get events and convert it into Redux actions. I lead to a lot of work. Can you suggest a better solution?
Yeah, so unfortunately, the best solution for approaching that is a complete refactor of your project. Every microfrontend should have its own Redux store, and the communication is happening through event emitter, like it is an external thing. And the reality of the things is, I know that is painful and it's not easy, but that's the way how you decouple things. Unfortunately, the moment that you have, let's say, coupling between microfrontends, as you probably experience, you start to have organizational coupling. And therefore, in that case, you are not going to have the best of any world, because you're going to have coupling between teams, and you try to decouple your code, but is intrinsic coupled because you have a shared or global state.
Right. So the next question is from Vic as well. I would like to deploy a micro front end to several environments, dev, QA, staging. Each of them has a different environment variable. There is a solution in using the public path in Webpack configuration. Can you suggest a better solution to solve the problem with the variant environment variables above?
To deploy several environments. Oh, okay, so there is a plugin for Webpack that is called, if I remember well, config path. And that one I can check later, but I think it's config path. And that one basically allows you to pass as a let's say environment variable for your Webpack script. So you just do Webpack and you set basically the variable that you want to pick, and then in the configuration you just do process.env.name of the variable, and you will be able to basically use the same script but orchestrate from externally. And in that case, we'll allow you to say, I want to deploy this chunk on testing in production or whatever it is.
Awesome. So the next question that we have is, what are the reasons not to use micro-frontends? What is the best way to find out if this framework is the right one for my web app?
I would say microfrontends are a nice addition to existing architectures. For instance, Jamstack, single-page application, server-side rendering are definitely still great architectures. Microfrontends are great when you have a lot of people working on the same application, or you have multi-tenant applications. Those are usually the main use cases that I have seen microfrontends applied. I have seen, for instance, also some freelancers or small companies that try to implement microfrontends. And my suggestion is always the same. Considering they require a lot of effort, instead of, at the end, what we have with microfrontends really is a strong encapsulation by design that is, let's say, created in the way that we are structuring our projects. Therefore, we have multiple independent projects. But you can have a strong encapsulation also at the code side. You can definitely, let's say, start to create strong encapsulation on the code side and then lazy load part of the code potentially. You are not going to have microfrontends, but you are going to have a way that then will allow you to migrate to microfrontends eventually, and is what usually they call modular monolith on the back end. And when we transition from monolithic architecture to microservices, sometimes you can go through this intermediate step called modular monolith that basically is slicing and dicing your application in multiple domains. And then you have these independent domains that are ready to be transformed to microservices, but the whole point is trying to reduce the cognitive load for the teams. Therefore, my suggestion is, if you are like a team of, I don't know, 5 people, 6 people, 10 people, and you want independence, try to work out on the code side more than thinking about immediately a microfrontend. Microfrontends are great, but they require a lot of effort for maintaining and making them shining properly. And therefore, you need to be aware that this investment is okay for your company or not.
Thank you, Luca. The next question that we have for you is, what is the best approach to convert my existing web page to one that is based on micro-frontend framework? What should be kept in mind while doing so?
So if you have an existing application, my suggestion is first start with data. So you can use whatever tool of analytics tool that you're using for understanding the behaviors of your users. And then from there, you start to define what are your microfrontends. You follow then the decision framework. And finally, you start to work on only one microfrontend, one that is crystalline clear, one domain that you really master. And you go end to end. So you develop, you create all the automation pipeline, you create all different staging environments and all the environments, and then you deploy in production. And that part has to live alongside the legacy application. In that way, you learn a bunch during the journey, but moreover, you are also experiencing if that approach is the right one for you or not. And usually, doing in this way, first of all, it will engage better with the business because they will be able to understand basically the value of this approach, and you cannot really understand if the things are going the direction that you expect. But moreover, if you need to pull the plug, the investment that you have made is not that big.
All right. So we've still got a bunch of time. We've got 10 minutes or so. So if you guys still have any questions, please feel free to drop them in the chat. My next question to Luca is, how can we manage dependencies between different micro-frontends?
So again, as we were discussing before, there are a few options. You can go custom and then say, every time that you have a dependency, you can create a GitHub repository and you show everything there. And then that will have its own pipeline that will create its own bundle and is available for everyone. Or you can use module federation that allows you to share the dependencies across multiple microfrontends, or System.js or import maps that allows you to do so. I don't have a preference. Again, it's as architect, I just need to know what are the options, and then based on the context, I will cherry pick which one is the right one. But usually those are the possibilities.
All right. So the next question that we have is, tell me more on CDN in Micro-Frontend, performance and usability.
Sure. I believe, and please correct me if I'm wrong, you are talking about edge side include, or you want to understand in general CDNs, how they play in Micro-Frontends?
Ajul, if you would like to elaborate. In general,
okay. So CDN are a great mechanism for caching static content, either an API or HTML fonts or whatever. There are a few aspects that I think are interesting of the CDN. A is that they are definitely more available globally than any origin. And the other thing is, nowadays they're also allowing you a bit of computation that it doesn't hurt, especially if you want to provide some business logic that is not happening on the client or server side, but you want that is happening just in time at the edge. So the CDNs are playing an important role wherever the implementation you're going to have with Micro-Frontends, because no matter what, you are going to have static content, or you have a page that is composed server side, but maybe vast majority of it is static. And therefore you can do that. And then if you have a CDN in front of your origin or your server, then these will allow you to easily offload the traffic to your origin. Therefore, you are going to pay way less on the origin side, because at the end, the response is coming directly from the CDN. That their main role is exactly that. So just reducing the throughput to the origin and serve as close as possible to the user request. The other plus that you have is, if you have a CDN, you can even reduce the security risk around your application, because often you have CDNs that are mitigating also the potential DDoS attack or flood attack, whatever it is. In the case, for instance, of the AWS with CloudFront, you have also you have Shield, standard Shield available out of the box, but you can have also Shield Advanced. That basically is a service that allows you to prevent, let's say, that kind of attack. And moreover, you have an Amazon team that is monitoring for you and helping you when the DDoS attack are happening. So there are a lot of benefits, in my opinion, of using CDNs. And despite you have, let's say, a lot to cache or not, also just for the security part, I think would be a great way to handle.
Right. Okay.
We have another one, apparently.
Yes, I do have a, I think we have time for 3 more questions, perhaps.
Okay.
So my next question for you is, how do you define the size of micro in this context? For instance, should I further divide my billing to invoice and payment? When do I stop further dividing my services? What is the ideal size of each of my service?
Yeah, that's the question that we don't have an answer. How micro is micro? I would say that you need to take, or at least this is my advice, based on my experience, I would say you need to take into consideration your organization structure when you struggle to see how far you want to go. If you divide your subdomains to, or in this case, Micro-Frontends, to fine grain, and you start to have a proliferation of them assigned to one team, you risk to overload this team. And that is, let's say, very complicated to handle. My suggestion usually is starting coarse grain, because then refactoring and splitting up is easier. You have everything there, you start to analyze. And for instance, it happened to me that we had like one team with one domain where we have a Micro-Frontends containing sign in, sign up, payment, and so on. And then we divided into experiences, the existing user experience that was the sign in, retrieve email, retrieve password, and the new user experience that was the sign up and payment. That basically reduced the cognitive load on the team. We split up the team in two and make everything easier to handle. Obviously, the moment that you have tens of Micro-Frontends in the same view, that for me is potentially could be something that smells. So I don't have, let's say, a number, say like 3 is optimal, 5 is not optimal. But when you have a lot of them and you start to see that there are more complexity to handle across teams, probably you need to sit down, take a step back and say, okay, is it really needed this kind of let's say, segmentation or not?
Thank you, Luca. And the next question that we have for you is, we have to support multiple teams for the MFE application. We are also using harvest pattern to collect components for the system design from the application. Could you suggest a solution to support the multiple team in MFE, in that multiple MFE can share them teams via CDN?
So let me read again the question. So we are using to collect components for the system design from the application. So to support multiple team in Micro-Frontends. Let me see if I get it. So you have multiple teams with the same Micro-Frontend, or you are creating one Micro-Frontend per team?
That's a big question.
A team for several Micro-Frontends. Yeah.
Okay, and Vic, you have like one team per Micro-Frontend, or you want to have multiple teams per in one Micro-Frontend?
I would like to have several teams for Micro-Frontends.
Okay, so in that case, it depends which technology you're going to use. For instance, I'm thinking with module federation, shouldn't be a big deal, for instance, something like that, but also with system.js or import maps, it won't be a big deal, because at the end of the day, what you need to do is separating the source of the system and probably, let me think. So what we could do, that it will require a bit of effort, but it really depends. If you are capable to, we should see, let's say, the case by case. But maybe if you try to create the similar styles, but with different, let's say, attributes, then you will have inside the Micro-Frontends the same code, but you load behind the scene the right theme, and as long the team has all the teams has the same, let's say, elements, then you can buy at runtime, you can load one team more than another one, and the code inside your Micro-Frontend won't be it won't change. Obviously, that requires an effort for making sure that all the teams are exactly the same with different attributes. So same API contract, same let's say encapsulation, and so on and so forth. But if you cannot do that, the only thing that I can think of is breaking even further your system through components and then lazy load the components, but that will require, let's say, a bit of more effort, and things can go wrong even further.
All right, I guess Vic's question is answered. So this will be our last question for Luca today. And the question is, how to deal with window exceptions in case of horizontal approach?
So when you have stuck again, so try catching your code, definitely. But when you have window, you have the global error handling. I don't remember the name. I'm sorry, on top of my head. It's unhandled error or something like that. That basically you can catch any error that's happening at the window. And then there you can centralize that, so you are not basically throwing an error and blocking the system, but it depends error by error based.
Awesome. Thank you, Luca. And that concludes all of the questions we received from the audience and
Great.
some from in-house. So that concludes our first panelist for today. We will be back in 5 minutes with our first lightning session speaker. Until then, if you guys want to go grab a drink, you can do so. If you want to connect to Luca, you can follow Leapfrog's accounts. You can get his details from there. You can get, if you did screenshot his details before, great job. If not, that will be available to you from all of LF's social handles. All right. Thank you so much, Luca. This was great.
Thank you.